On January 21st, 1910, Paris was hit by a sudden flood that wreaked havoc on the city. Buildings were destroyed and the subways submerged in water. But an even stranger fact was that almost all the clocks in the city stopped at exactly 10:50 a.m., as if in the midst of the chaos, time had decided to stop. These clocks were connected to a unique network of underground pipes that, by means of blasts of air, synchronized the time throughout Paris. Such an ingenious system was devised in 1880 by Victor Popp, an Austrian engineer. Only 5 years later, the city saw the installation of thousands of these clocks in places as diverse as hotels, train stations, homes, schools, and public streets. We reconstructed the workings of this extraordinary system and the central machine that animated it to illustrate how an intricate web of underground pipes and mechanical clocks managed to keep the entire city synchronized. Before accurate electric clocks were invented, synchronizing time was a challenge. Mechanical clocks tended to lose synchronicity gradually, leaving each on a slightly different time. This made business meetings and train schedules a real problem, as no one could be sure of arriving at the right time. The very idea of an exact time was then unclear. Bells in city towers announced the hours, but as urban civilization progressed, it was no longer enough to know the approximate time. The need was felt to ensure that everyone had the same time, to the minute. Thus was born the idea of a capable clock, located in the heart of Paris, to send a signal every minute to synchronize all city clocks. Electronic signal transmission was cost prohibitive, so Popp opted to use air blasts, a cheaper and more reliable method. The clocks did not need to be electrically powered. Air puffs were enough to move them simultaneously. This concept had already been successfully tested in Vienna a few years earlier, proving that standardizing time was essential for the future. As a result, the Parisian government entrusted Popp and his team with a 50-year contract to supply the city with time. The pneumatic clock company settled in the center of Paris, resulting in the master clock, an extremely precise mechanism capable of running without interruption 24/7. To understand the operation of this incredible machine, it is necessary to know the basic principles of mechanical clocks. Generally, the force of a spring or weight was used to generate power. By lifting a weight, potential energy was stored, which, when released, allowed the wheel to turn due to the force of gravity. A clock that ran out of charge in a few seconds would be useless, so an escapement mechanism was introduced to moderate the descent of the weight and generate a regular beat. The pendulum, swinging back and forth, adjusted the movement of the wheel at constant intervals, slowing the release of energy. By changing the length of the pendulum, the speed of the clock could be adjusted. The addition of a high-ratio gear system further reduced the speed, allowing the weight to power the clock for a full week without the need for winding. Victor Popp's master clock, located in the heart of Paris, was divided into two distinct sections. On one side, we find a traditional pendulum clock that controlled the hour, minute, and second hands. On the other, there was a timer-like device in charge of managing the release of air blasts within the network of clocks. But how was the synchronization of the master clock maintained? At the Paris Observatory, another clock of superior precision was located, regularly adjusted according to astronomical observations of stars and planets. When needed, the watchmaker would update the master clock using the one at the observatory as a reference. From the master clock, compressed air was then distributed through 10 main pipelines, each of which directed to different parts of Paris. These pipes carried air through a network of iron pipes that stretched for hundreds of kilometers, passing through the tunnels of the city's subway and sewer systems. As the compressed air advanced through the pipes, a pressure wave was generated that propagated throughout the system, taking up to a minute to reach the most distant clocks. But what was the effect of the arrival of air on the clocks? The construction of the clocks was actually quite simple. The minute hand was connected to a gear equipped with 60 teeth. When air arrived, a bellows would inflate, pushing up a lever that in turn moved the gear forward one step thanks to the intervention of a moving tooth. Another tooth positioned on the opposite side prevents the gear from moving backward. When the bellows deflated, the movable tooth shifted, allowing a small counterweight to keep it engaged with the gear. thus ensuring that each full inflation of the bellows advanced the gear by exactly 1 minute. The hour hand was connected to the minute hand by a transmission ratio of 1:12, ensuring that the minute hand completed 12 revolutions in the time it took for the hour hand to complete 1. This system was not reserved only for public clocks or railway stations. Anyone could have one of these clocks in their home by subscribing to a subscription for a modest sum, corresponding to 30 cents a day in today's value. Despite being damaged during the Great Flood of 1910, this extraordinary system continued to operate for almost half a century until 1927, when the reliability of electronic clocks became such that the old system became obsolete. Today, the original clocks no longer exist, but signs of their former presence can still be seen in various parts of Paris. The video is concluded. I hope you enjoyed the story, and I invite you to subscribe to the channel for new content like this. See you soon.